So we're celebrating the prep class having the ability to increase test scores by about 2 points. But now there's some cautions. How do we know it's a prep class? What else were students doing to try to raise scores? Lots of times they buy a little test book and they study off the test book. They work together with their friends on other things. The prep class might just be one thing they're doing in a whole pattern of activities trying to raise their scores. So maybe we can't attribute the increase in scores just to the class. And then wait a second, maybe anyway, maybe your score automatically goes up on a second try. After all, you've seen the questions once already. Maybe on a second try, you just do better even without the test, the prep class. So how do we know what's going on? We'd have to do a more carefully designed experiment. These kinds of before and after experiments are subject to all kinds of extra variables which might be influencing the outcome, including the passage of time by itself. In any case, we can make a confidence interval to see how big an increase we might expect to see. We don't really know what the other situations might be these people were experiencing, but if these are just typical people that are just doing a prep class, would they think they would get a 2-point increase? Well, here's how big an increase. The confidence interval says the average increase is somewhere in this interval, most likely. So we create an interval using 95%. Here's the t-star value. We use the sample mean. We use the t-star. The s was 1, n was 9. So x bar plus or minus t-star s over root n. And here's the interval, 0.9 up to 2.44. So somewhere between 1 and 2 points, almost you can't get 2.5 points, but on average you could get 2.5 points. So lots of people will get 2, some people get 1, so that would average out to 2.5. So on the average increase is based on the data somewhere between 0.9 and 2.44. And the sample size is small. That's why it's such a wide interval, and it could be only as big as 1, or it could be bigger than 2 on average, as a response to having gone through the prep class. If we wanted to be more clear-cut about how many points you can expect to gain, if you're going to pay $200, you want to at least get something for it, you'd have to look at a larger sample, and you have to be more controlled. You'd have to be able to find out, make sure that's the only thing the students were doing, and have already had some experience with the before and after. Second time on a test with no, I guess you could have a control group that doesn't have a prep class, does everything else the students did, and then half the students would then go through a prep class, the other half the students would do everything else you might do in that time frame, knowing you're going to take the test again. And then we compare those two groups in what's called a two-sample t-test as opposed to a matched pairs test. We haven't got there yet. So we're going to see how we could compute all this stuff on the calculator. I have entered in, I think I've entered in, the values, before and after values, into the lists. So I'm in stat edit, put that here. Stat edit brings up that screen, and then I've entered in into list 1 and list 2 the values, and then I'll have the calculator do some list arithmetic to compute the differences. So you go back to the home screen, so I go second quit, and then I go second 2, which is list 2, minus second 1, which gives me list 1. And I hit the store button, it's right above the on button, and I go second 3. So list 2 minus list 1 stored in list 3. What that does is it creates a new column of data, which is this minus that. I'll go back to stat edit. I'll go back to stack edit. I'll go back to stack edit. Hang on, stacked. Oh, stat edit, here we go, enter. And now I've got over here 3, 2, 2, 0, 2, 1, 1, 3, 1. I'm scrolling down to make sure. Yes. And then I can go ahead and do the t-test we just did and the t-interval we just did. I get out of here, second quit. I go to stat tests and 1 down to t-test. And then input is data. The null hypothesis mean was 2. The list of the differences is list 3. Frequency, there's a frequency table you can use sometimes. Ordinarily that's just the number 1, because for each value that appears in list 3, it only appears once in the data set. You could have other lists which say how many 3s there were, how many 2s there were. Almost never happens. And then we go down to the alternative. We want the less than 2 alternative, so the middle one, less than mu naught. We go to calculate, hit enter. And I get a t of -1 and a p-value of 0.17329, etc., and some other stuff. So we look at this p-value. We said it was bigger than 0.05. It was actually bigger than 0.15, between 0.15 and 0.2. There it is, 0.17, between 0.15 and 0.12. Verified our calculations. And we'll go ahead and make the same interval we just made. We'll get out of here, second quit. Or second clear. Okay, clear. We go to stat, tests, and we scroll on down to t intervals, number 8. We hit enter. Data, list 3, frequency, confidence level 95%. Calculate. Bang. And it has 898 up to 245. Gives you x bar, gives you sx, gives you 9. It matches what we got for our interval. We rounded ours to 244. So that's kind of cool. You can also do all those z-tests on the calculator. It's quite useful for checking your work, but on an exam situation, we're going to want to see the work that's done to obtain the data values. So, but you can use your calculator to make sure you didn't make some kind of silly mistake. There we go. One more slide and we're done with this chapter.